You've trained a classification model, e.g., logistic regression, to predict customer churn. Your model outputs probabilities. But how reliable are these probabilities? How do you assess and improve the calibration of your model's probability outputs? A. Use calibration curves, e.g., reliability plots, to visualize the model's probability calibration. B. Employ calibration methods like plot scaling or isotonic regression to adjust probabilities. C. Evaluate calibration using metrics like bias-score or log loss. D. All of the above. A. Calibration curves reliability plots visually demonstrate the relationship between predicted probabilities and actual observed frequencies, helping you identify any calibration issues. True. Calibration curves, also known as reliability plots, provide a visual representation of how well a model's predicted probabilities align with the true probabilities. They plot the predicted probabilities on the x-axis and the observed frequencies or proportion of positive instances on the y-axis. A perfectly calibrated model would have a diagonal line, indicating that the predicted probabilities match the actual outcomes. Deviations from this line indicate calibration problems, allowing you to identify areas where the model is overconfident or underconfident in its predictions. B. Employ calibration methods like plot scaling or isotonic regression to adjust probabilities. True. Calibration methods like plot scaling and isotonic regression are techniques used to adjust a model's probability outputs to better reflect the true probabilities. Plot scaling is a sigmoid-based method that adjusts the output probabilities by fitting a logistic regression model. Isotonic regression, on the other hand, uses a monotonic function to adjust probabilities, preserving the order of predictions while improving calibration. These methods are often applied to improve the calibration of models that exhibit systematic biases in their probability estimates. C. Evaluate calibration using metrics like bias-score or log loss. True. Calibration metrics like bias-score and log loss quantify the calibration error, allowing you to assess the accuracy of a model's predicted probabilities. The bias-score measures the mean squared difference between the predicted probabilities and actual outcomes, while log loss measures the average negative log likelihood of the predictions. Lower values of these metrics indicate better calibration, signifying a model that produces probabilities that are closer to the true underlying probabilities of the events. D. All of the above. True. All three choices are essential for assessing and improving the calibration of a model's probability outputs. Calibration curves provide a visual understanding. Calibration methods adjust probabilities, and calibration metrics quantify the error. Combined, these approaches offer a comprehensive strategy for ensuring reliable probability estimates from your machine learning models. D. All of the above. Probability calibration. Probability calibration refers to the process of aligning a model's predicted probabilities with the actual frequencies of events. It ensures that the probabilities accurately reflect the likelihood of an event occurring. Calibration curves reliability plots. Calibration curves, also known as reliability plots, visually depict the relationship between predicted probabilities and actual observed frequencies. They help identify any calibration issues and assess the model's confidence in its predictions. Calibration methods. Calibration methods are techniques that adjust the model's probability outputs to improve their alignment with the true probabilities. Common methods include plot scaling and isotonic regression. Calibration metrics. Calibration metrics, such as bias-score and log loss, Quantify the calibration error of a model. Lower values of these metrics indicate better calibration, signifying a model that produces probabilities closer to the true underlying probabilities. sklearn calibration module. The sklearn calibration module in scikit-learn provides functions and classes specifically designed for probability calibration. It includes tools like calibration curve, calibrated classifier CV, and Brier score loss, risk assessment. Financial institutions utilize calibrated models to assess credit risk. Accurate probability estimates are crucial for making informed lending decisions, ensuring that loans are granted to individuals with a high likelihood of repayment and minimizing financial losses. Medical diagnosis. Calibrated models in healthcare play a vital role in providing reliable probability estimates for disease diagnosis. These models assist medical professionals in making informed patient management decisions, such as recommending further tests or treatment plans, based on the likelihood of specific conditions. Fraud detection. Calibrated models are essential for detecting fraudulent transactions. Accurate probability estimates help prioritize investigations and minimize losses by identifying transactions with a higher likelihood of being fraudulent. This allows organizations to focus their resources on the most suspicious activities and reduce the impact of fraud.